Namaskar friends, welcome to session 32 of our course on manufacturing guidelines for product design. So currently we are in the 7th week of our discussion on this important topic, and in the 7th week we have started to discuss the important joining techniques for plastics. And the last session, if you remember, in session number 31, our focus was induction welding of plastics. So some of you may be wondering that how this is related to our topic, which is manufacturing guidelines for product design. Now basically, when we are designing a product, what are the important things that we have to keep in mind? And if you remember, in the very beginning we have seen a triangle in which the product quality is dependent upon three important things. Now these three important factors are the materials that are used for making the product, the manufacturing process that is adopted to manufacture the product, as well as the design of the product. So all these three things, or three sides of a triangle, are important to ensure the quality of a good product, or to ensure a good quality product. So that is the basic premise which helps us to focus on these important areas. Now suppose we have selected a plastic material for our product, and we have seen in the previous session that why do we need to join the various plastic parts together, and we have seen that there are 3 or 4 important reasons which help us to justify the joining of plastics. Now what are these 3 or 4 reasons? The first reason was that the traditional or the processes that have been commercialized for making of plastic parts, such as the injection molding process, the compression molding process, the rotational molding, thermoforming, extrusion, these processes are not suitable for making very complex large size plastic products. So therefore we need to develop the product in smaller parts, and then we need to combine them together to make a bigger or a larger assembly. So therefore the joining becomes important. So the first maybe justification for joining of plastics is that when we need to develop bigger large size products, it necessitates the process of joining. First justification. Second justification is that many a times we need to disassemble the product in order to ensure the maintenance or the serviceability, and for that purpose also we require to join the parts so that it is easy to disassemble them. Moreover, cost is the last parameter which is very important. For making a very big size plastic part, the mold also has to be bigger than the product, and to justify the cost of a bigger mold we must produce in large numbers. So we must have large number of parts to be manufactured, then only the cost of the mold or the die can be justified. So it is better that we can make the product into smaller parts using less tooling cost, and then assemble the product to get the final assembly or the final product. So therefore the joining of plastics is an important area. So therefore it is related to our context of product design also, that when we are designing a product, the material we have already selected that it is going to be a plastic material, we must know that how this parts or these parts or how this product is going to be assembled. So that is the most important justification of covering this topic in our course, that the material selected is plastic. The product design has to be modified to ensure that these plastic parts are assembled together, and therefore we focus on the manufacturing technique. So 3 triangles will ensure a good quality product. The plastic, the design has to be modified, and the joining has to be ensured so that we are able to produce a good quality product. And for that purpose only, in this week our focus is primarily to identify that what are the various processes which are widely being used for joining of plastics, what are the salient design guidelines that we must keep in mind when we are designing the products which are to be made by plastics, and finally try to see the good quality plastic products based on these guidelines. So the joint configuration or the joint designs are almost similar. We have already discussed the various joining techniques like adhesive joining, mechanical fastening, welding, brazing, soldering. So most of the joining techniques we have already covered in the previous week, and the various design guidelines also have been covered in detail. So most of the joint configurations remain same, but there are some specific guidelines, as we have seen towards the end of our previous session in induction joining or induction welding of plastic, that there are few specific guidelines which are specifically relevant to the induction welding process, which we have seen yesterday. And today also we will divide the complete discussion into two broad parts or two broad classifications. That is, initially we will try to see the fundamental aspects of ultrasonic welding of plastics, and then we will switch our attention to the next stage, that is, what are the important design guidelines related to the parts which have to be joined by using the ultrasonic welding process. To start with, let us see that what is the ultrasonic welding and how it is relevant for the plastics. So let us see, this is a very simple diagram on your screen. Here we can see this is a horn. If it is not clear, I can write it again. This is the horn. So this is given a vibration or at ultrasonic frequency. We can see the force is applied here. Already it is shown, there is a force here. So basically this load will ensure the two parts are in contact. Now what are the parts that we are joining? This green portion is our first part, and the orange portion is our second part. So these are the two adherents that we want to join together like this. And what is this joint configuration known as? All of you know, we have already seen, it is a lap joint configuration. So the two parts that have to be joined together have been placed like this, and on top maybe like this, and on top there is a force that is acting, a force has been applied on top of this. So the two parts under lap configuration are in constant contact. Now there is a ultrasonic vibrations given in this direction, it is clearly shown here. So in this direction at 20 kilohertz or more, so you give the ultrasonic vibration, the two pieces rub against each other and a heat is generated at the interface between the two adherents. One of the adherents is represented by green color, the other adherent is represented by the orange color here. So when we produce the heat between the two adherents, a joint is produced. So ultrasonic welding of plastics is the joining of thermoplastics. It is written clearly, thermoplastics. All of you know that polymers can broadly be classified into two categories. One is the thermosets and the other category is the thermoplastics. So this is well known to all the learners. And here we have highlighted that the ultrasonic joining of plastics is most suitable for joining of thermoplastics. So ultrasonic welding of plastics is the joining of thermoplastics through the use of heat generated by high frequency mechanical motion. So there is a mechanical motion between the two adherents, as is shown here in this direction. Direction is clearly indicated, and this continuous mechanical motion between the two parts produces lot of heat. And if you see that in joining, normally two important parameters have to be controlled. We must try to understand that. And yesterday also I defined the welding process. Again today I will speak about welding for a minute or two. Now welding is a process of joining two similar or dissimilar materials with the application of heat, with or without the application of pressure. So the heat is an important input for any joining to take place, and here the source of heat is the relative motion or the mechanical motion between the two adherents which have to be joined together. In our previous case, we have seen when we were trying to join the two plastics together using the induction heating mechanism. So the source of heat was the electromagnetic induction heating. Prior to that, in brazing and soldering, we have seen that we melt the alloy and the alloy penetrates with the help of capillary action between the two adherents or the two metal pieces which we want to join together. In electric arc welding, the source of heat is the electric arc. In case of gas welding, the source of heat is the gas or the fuel gas that we use or that we burn for producing the flame. So different types of joining processes have one commonality, that is they have a source of heat, and here the source of heat is the mechanical motion or the friction between the two adherents. So the heat is generated from the high frequency mechanical motion between the two adherents. So if we have understood that what is the process of ultrasonic welding of plastics, we can very easily be able to appreciate the kind of design guidelines that we must keep in mind when we are designing parts which have to be joined using the ultrasonic welding technique, and specifically the plastic parts that we are designing which needs to be joined using the technique which is the ultrasonic welding technique. Now let us see the next stage or the things that I have already tried to explain from the diagram. It is accomplished by converting high frequency electrical energy given to the horn into the high frequency mechanical motions. So the two parts rub against each other under the applied force. So the mechanical motion along with the applied force creates a frictional heat. Already I have discussed this word. So this is the most important source of heat in case of our ultrasonic welding. So this is most important. So when our electrical energy which is supplied to the equipment is converted into the mechanical motion at high frequency between the two adherents to be joined, when they rub against each other, heat is created, and this frictional heat is used to join the two thermoplastic parts together at the mating surfaces of the plastic component. So this frictional heat which is generated at the mating surfaces of the plastic components, maybe at the joint interface, localized maybe joint is formed at the lap interface. So this is the movement between the two pieces, and at the joint interface localized maybe melting and resolidification of the thermoplastic may take place, forming a joint between the two plastic parts. The frequency 20 to 40 kilohertz. So the frequency, as we have already discussed, is in the range of 20 to 40 kilohertz. Now let us see that what are the various design guidelines that we have to follow when we are designing parts which are made out of plastics and which we plan to join using the ultrasonic welding technique. Now what are these guidelines? One by one we will try to see, and with the help of the diagrams we will try to understand that how we must design our joints so that they can be in mechanical motion under the frequency which is just mentioned, so that frictional heat can be used to produce a joint between the two mating parts. Now we can see on your screen, this is our first part, this is our second part, and we want to join them at this interface. So the width is also given W. Now let us see now what is written on the screen. Surfaces of the plastic workpieces to be joined should be free of distortion and warpage. This is first requirement, should be free from distortion and warpage. So very important. Why? You can see here, for example, this is my one surface and this is the another surface, and as we have seen, when we want to join them together, we apply a force here and then we create a mechanical motion between these two parts. This is the first part and this is suppose the second part. When the surfaces are not aligned properly, there is distortion or warpage at the joint interface, we will not get a good joint. Therefore we have seen that the surfaces must be straight as indicated here, and we will discuss what is the need of putting this indicator here maybe in the next sentence. But first thing, we must ensure that the surfaces of the plastic workpieces, this is workpiece number 1 and workpiece number 2. So surfaces of the plastic workpieces to be joined should be free from distortion and warpage. So this clearly helps us to highlight the importance of the preparation of the surfaces which have to be joined using the ultrasonic welding technique. So this will lead to a poor joint because the surfaces have distortion and warpage. Now coming to the second guideline which is given on this screen, bead or narrow raised sections. Narrow raised sections. So this is the narrow raised section which is shown here. So this is a narrow raised section which is after the welding. This is after the weld, this is before the weld. Now bead or narrow raised sections, these are called the energy indicators. What is the need of these energy indicators? Energy indicators are molded on one of the surfaces. So when we are making our two parts or designing our two parts, this is our part number 1, this is part number 2. So when we are designing these two parts, we will try to mold a energy indicator during our primary forming process only. Now this primary forming process can be anything. It can be compression molding, it can be injection molding, it can be maybe thermoforming. So any process we are using for making these two parts, and then these two parts have to be joined together. So during the molding stage only we will put this energy indicator, and this energy indicator, why it is required? So the energy indicators are molded on one of the surfaces of the workpiece. This smallest possible surface area increases the frictional heat and in turn the melting rate. So this smallest possible surface area of the energy indicator increases the frictional heat. As I have already indicated, the frictional heat is the source of heat which is required for joining the two plastic pieces. So in turn it improves the melting rate. As I have already told, when localized mechanical motion takes place between the two surfaces, there is a frictional heat that is produced, and the localized maybe melting of the plastic in that area and then fusion of the two adherents together after the melting of the plastic in that area may be the reason for the joint being formed. So we need to understand, because that will vary depending upon the type of thermoplastic that we have selected, depending upon the range of frequency that we have selected, depending upon the load that we are applying on the joint that we are making. So depending upon a lot of parameters, we will be able to establish that what is the mechanism of the bond that is formed between the two work pieces which are of plastic material. So the mechanism in general will be localized heating, melting and solidification in general, but specific needs to be investigated and established. So here we can see that in order to join the two plastic pieces, there is one design guideline that energy indicator or maybe a very small raised section can help to increase the rate of heating and that of the, and then increase or accelerate the melting rate at the surface where the joint have to be formed. So this is the initial stage, then this is the second stage after the weld, and this is the final butt joint with energy indicator. So a good joint, here we can see this is the joint which has been formed. So this is our part number 1 and the part number 2 that we have joined using the ultrasonic welding technique. Now here we can see the step joints are more, so this is the third guideline. So if we go back to the previous slide and try to see what are the guidelines we have seen, there must be no warpage or distortion in the surfaces that we want to join. Secondly, energy indicators or little molded portions at the surface during the molding stage can help to increase the frictional heat as well as the melting rate. So the third guideline is step joints are more preferable to reduce the unwanted flash and to increase the joint strength. So two important advantages are there with the step joints. One is unwanted flash can easily be avoided and it increases the joint strength. So it is always our endeavor, it is always our aim, goal, objective to achieve the maximum joint strength whenever we are joining the two parts together. So step joint help us to achieve our objective of a very high joint strength. Let us see now what is a step joint. Here we can see again there is a energy indicator. So, we can use these guidelines in synergic manner also, that we can use the energy indicator also, as well as the joint configuration can also be changed to take advantage of both the guidelines. So, this is an example of an energy indicator which is mentioned here or which is depicted here. And now this is our first part, this is our second part. So, these two we want to join together, and how they will be joined together, this is the width of the workpieces. Again we will apply load in this direction and the vibration can be given, and then because of the relative motion mechanical forces will act, frictional heat will be produced, and that frictional heat will help us to get the joint, and this is the joint which has been achieved. This line, red line, now indicates the final joint which has been achieved, and this is what we are calling as the step. So, this step joint will give us better joint strength and as well as will reduce the unwanted flash which can otherwise be generated. So, we can see here there is a slip fit also which helps that to join the two parts together. So, basically the guidelines are also given that what must be this W by 3, this area is given here, and then what must be the step size here which is also indicated. So, this is in terms of the W parameter which is there already known to us from the dimensions of the plastic part that we want to join. So, from the dimensions of the plastic part very easily we can calculate what must be the step size, what must be the slip fit, and accordingly then we apply the vibrations or the ultrasonic vibrations, and accordingly because of the frictional heat we will be able to produce a good quality joint. So, if we take into account all these parameters when we are designing the plastic part, they will help us to design the parts in a better manner so that their joining is also effective and efficient. Now, the fourth guideline we can see here, three guidelines already we have seen. Even a greater strength is possible by using the tongue and groove joint. So, previous was the step joint. What were the two advantages? It will minimize the flash, it will improve the joint strength. Another guideline, the joint strength can further be improved if we can use the tongue and groove joint. So, what is this tongue and groove joint? It is shown in the diagram. Again the parameter, geometrical parameter for our plastic part is given W, and all other parameters are in reference to W only. This is W by 12, this dimension, and this is W by 3, the depth up to which our tongue is going. So, this maybe we can call this top portion as the tongue, and the bottom portion where we have this slot can be called as the groove. So, we have tongue and groove type of joint here, and again you can see there is a, what is this? Now, by now you must be easily able to identify, which we have already covered. This is an energy indicator. So, when we will form the joint here, the joint will be formed like this after the ultrasonic joining. So, tongue and groove joint gives us even better strength as compared to the previous joint which was the step joint. So, this is the tongue and groove joint which is most of the times called as the best joint for joining the two plastic parts together using the ultrasonic welding technique. But molding this type of joint is little bit difficult. So, because initially we need to make this part and the corresponding part which have to be joined together. So, molding of these parts may be slightly difficult in comparison to molding the straight surfaces. So, maybe with little difficulty, if we can optimize this process or this design, we can very easily get very high joint strength using the tongue and groove type of joint. So these are the recommended joint designs for ultrasonic welding of plastics. We can see what are the types of joints. You can see here, this is the joint we are getting after ultrasonic welding. Maybe it can be called a L type joint. Then this is another, we can have a joint line here and a joint line here, which is final form is shown like this, you can see. Then again we can have a joint line here and a joint line here, which is shown here. The two parts are joined. After joining, this is our joint line, and similarly we can further redesign the part to get a this type of joint. So these are some combinations of the joint configurations which can easily be adapted for ultrasonic welding of the plastic parts. So typical ultrasonic joint design. So these are better designs. Previous to this, we have already seen two types of design, which one was a step, another one was tongue in groove. So various types of joint configurations can be adopted. The basic principle that we have to keep in mind is that we apply a force, then we keep the two adherents together, joined together, and then we apply a 5 frequency mechanical force between the two, which generates frictional heat, and this heat is a source of joint or the joining between the two plastic parts. Now depending upon our product design, whatever possibilities exist, if we have the idea about different types of joint configurations, we can select the best joint configuration which can give us a high strength, least or minimum warpage, least or minimum flash. So accordingly we can join the two parts together according to our design. So during design only we must keep into account or keep in mind all these design for configurations which are possible for ultrasonic joining of plastics. Now this is the last slide for today. So it is not recommended to bevel one surface of the joint. Another important guideline. This is related in fact to the first guideline that we have seen, that when we have two parts with warpage or distortion, we may not get a good joint. Similarly, if we in this is an higher order case of this type of joining or this type of problem, here we have a bevel here, you can see. So it is not recommended to bevel one surface of the joint. So this is the flat surface of the joint, this is the bevel surface of the joint. So it is not recommended. Why? Because when we do the ultrasonic welding, there are chances of bonding not occurring in these two regions. So these are poor joint characteristics. So not bounded, no bonding has taken place in this region and in this region. So developed strength limited by the portion of the cross section. Now what is the portion of the cross section? This is the portion of the cross section where actual bonding has taken place, and outside there is no bonding which has taken place. Why? Because of the bevel nature of the one of the adherents or one of the plastic parts which is joined to a flat surface of the other plastic part. So another problem is large volume of material expelled beyond the joint. So this is another problem. Full weld. So this is a partial weld. So this is before weld. So we are moving in this direction in terms of time. So initially this is the case, maybe we can call it as step 1. Then after this, when we start the process, this is our step 2 in terms of time, and this is our step 3, which is the final or the full weld. So the butt joint with bevel edge, this is not a good design, it is a poor design. So we must avoid a bevel type of surface when we plan to join the two surfaces, one being flat, another being bevel. We will not be able to get a good joint strength even after adopting the ultrasonic welding technique. So with this we can conclude the today's session. What we have tried to understand today, we can broadly classify the understanding into two parts. Initial one is the basic fundamental of ultrasonic welding of plastics. We have seen a diagram how ultrasonic welding is done, and finally we have switched our attention towards the various joint configurations that we must keep in mind when we are designing our products. So in our product, if 2 or 3 plastic parts are there and we have to join them together using the ultrasonic welding technique, we must plan, we must select our joint design judiciously so that we get a good quality joint. In our next session, our target will be to focus on another welding technique or joining technique which is used for joining of plastics. With this, we conclude the today's session. Thank you.